in a couple of minutes. Then 3 presentations of our estimated guests here, so Green Charge, Meister, and Instant EV projects, and then followed by a question-answer session that will be moderated by my friend and colleague Jan. Then will be a closing, and that's it. So just a few words, maybe just to set the scene. As I said, these 3 projects that will be presented today in this session will concern the innovation in the area of charging and understanding user needs in European cities. We know that there are still many obstacles for a widespread European network charging infrastructure and to travel within EU with an electric vehicles. The availability of charging stations varies between countries, the payment systems are not harmonized yet, and there is an inadequate information for the users. Research innovation obviously can help to set the path through by analyzing, testing, and demonstrating the innovative solutions, and better detail the most relevant business cases that can be quickly brought to the mass market. Obviously, this is clearly in line with the objectives of the Green Deal and the zero pollution strategy, without forgetting the smart and sustainable transport strategy and the Fit for 55 proposal. Road transport is asked for an irreversible shift to zero-emission mobility. We also should remember that all activities under 2.0 mobility shall strongly help and support the Repower EU to accelerate the deployment of cost-competitive solutions for the use of renewable electricity. This obviously would also help the optimization of the electricity market, so with a systemic approach, which is in line with what we're doing in the 2.0 partnership under Horizon Europe, just started. What is the context of urban mobility and charging of vehicles? Well, we know that urban mobility poses major societal challenges related to congestion, to safety, greenhouse gas emissions, and quality of air. We need affordable and friendly charging solutions. These are essential for widespread usage, especially in urban areas. Some of the challenges range from the availability of charging to ensuring that the grid is not overloaded if all the people is charging at the same moment. One of the biggest mistakes, as Ian was saying, people could make in approaching the charging is doing the same way as we're refilling today, just fill it up. Obviously, the challenge is to actually implement solutions on a mass scale, especially because we have many options available, and we will hear it from the project. So the project will need to go, and they will present what is beyond the simple event of charging, to include how to tackle potential new business models, and even exploring different ownership models, also absolutely reducing the number of vehicles. We need the system to become really more intelligent in the future to optimize the use of existing infrastructures. For example, Green Charge will be presented, but also we will have to consider, and this is of utmost importance, the user's needs and how these needs might change also in the future. Let me conclude here, and then I would ask now the first speaker, which is Jacqueline Ploch, Senior Researcher at Sintef Norway, with more than 30 years of experience in the field of software engineering, to present the project Green Charge, which started in 2018 and just finished it in February 2022. So we'll be able to hear the main result and the lesson learned. We're also with pilot in Oslo, Bremen, and Barcelona. Jacqueline, the floor is yours. I just ask you, as we discussed, we need to stay within the 15 minutes allocated time, so to leave the time for question and answer, that we follow all the 3 presentations. Thank you. Floor is yours.
Thank you. Good afternoon. So I'm going to present the Green Charge. We have completed the project last of February. We were 17 partners from the south to the north of Europe, and almost 50 person years. So what it is about? So we see a transition to electric mobility. And we also see that people are going to share different kinds of vehicles, cars, bikes, scooters. And we have 3 main concerns. Making people confident that they can get charging when they need. And with people I mean private owners, but also EV fleet managers. Thinking about where does the energy come from and balancing production and consumption, and getting the right business model in place. Related to those three concerns, we have defined objectives. Our objectives were to test and to develop and test different solutions related to those concerns. I want to talk a bit more about smart energy management, because we have discovered that this is not something that is well understood in the transport domain. So we know that to achieve the CO2 emission reduction, we have to become electric. And this, of course, is challenging because it leads to stress on the infrastructure. And also we have to have green energy. And the problem with electricity is that consumption and production have to get balanced. So, concerning charging, look at this example from Norway, where the society is highly electrified, and also we have a lot of electric cars. You see that when people get at home, we have a peak, we stress on the infrastructure. And the same with electric cars. When people come home, they charge, and this double the peak. And of course, this means that the infrastructure has to be adapted to that. Well, smart energy management is a mean to avoid that. Today, we have some solutions that are called smart charging, but actually they are not so smart. They react to what is happening and they try to spread the load. But the problem with that is that if some people need to charge quickly, it does not work. So smart energy management is about being able to predict what are the needs and to fulfill those needs. And the prediction is based on historical data, but also on other things like what is the production of green energy today? What are the costs? So all those parameters can be combined to adapt the charging. And there are many benefits of that, is that we can increase the self-consumption of the energy produced locally. We can reduce peak load. We can also charge when the prices are low. And we decrease grid investment. So, I come back to Green Charge. So in the project, we had created innovative scenarios relating to charging, to energy management, to EV fleet management. Those scenarios, we have specified how we can implement it. The main result of our project is the reference architecture. That is a mean to understand the context and to realize solutions. And understand is very important because it's very difficult because there are many stakeholders involved from different domains, from transport, from energy, from buildings. This reference architecture is not a document only targeting technology developers, but also targeting policymakers, urban planners, because we describe the stakeholders, we describe what drives them, what are the barriers, and how we can overcome those barriers. So it's a document that targets many different people. Another important result from our project is the evaluation framework. It is based on the Civitas evaluation framework, and it defines different measures, if you want, or action that we can introduce in order to make this transition to electric mobility possible. So there are measures relating to charging, to energy management, to EV fleet management, and to business. We have defined 24 different measures. And we also define how we can evaluate the effect of introducing those measures. We have defined indicators, performance indicators, and algorithm to calculate them. What data do we need to calculate, and how do we calculate? For example, so the measures, they relate to each other, in fact. If, for example, one measure is about an optimal use of energy, but to make this possible, we need flexible charging. That is, the user does not necessarily need to charge at once, but it can be more flexible and wait or charge less depending on what is going to do the next day. And to motivate the user to be flexible, we also define measures relating to business incentive to make people be flexible. We have 3 pilot cities in the project with different mobility culture. We have Oslo with a very high density of electric cars, and in residence we don't have the possibility we don't have the charging infrastructure in place yet. We have Bremen, where Bremen is very concerned about reducing car usage and sharing cars. And we have Barcelona, where we have many light electric vehicles. So for those pilot cities, we have defined different demonstrators. We have 7 demonstrators. They don't implement all the measures we have, but some of them. And for those, we also evaluate the effect of introducing the measure. I don't go in details here. We have defined demonstrator cars that are available on our sites, and you can go and look closer at. So we, of course, have to realize we have technologies that realize the solution to implement those demonstrators, and those technology, they are taken in use the reference architectures that we have been developing. So the reference architecture is a support to implement, to integrate solution. And on the way around, the integration also has made us learn how to enhance the architecture. This is an example of demonstrator cars for the Oslo demonstrator, where we are focusing on energy smart neighborhood, and where we look how we can make use the energy in an optimal way, not only for charging, but also for all other needs in the buildings. So, yeah. What do we learn for our demonstrator? An important lesson is that it's very complex. We integrate many systems from different domains, and there's a lack of standardized interface. So in our architecture document, we describe how different systems can communicate to others, and this is the basis for standard. Business model. So we have also developed business model for each of those demonstrators, and we have demonstrated in 2 cases, in Oslo and Bremen. We use a bit an untraditional way of building those business model because we have several actors involved, and then we are inspired on the sharing economy concept, and we wish that the different actors that are involved all benefit from this cooperation, not only financially, but also socially and environmentally. So we have different kind of incentives here. So what we learn when we make those, that we multi-sided marketplace is a better approach than the conventional model per stakeholders. We also see that the sector or the domain of e-mobility is still unstable. It's immature. You have to find what kind of incentive we have to introduce. And of course, we have to motivate people for changing behavior. So we have evaluated our solution, and we have developed an hybrid evaluation approach that use both real data for demonstrator in order to calculate the effect of a measure, but that also use simulation. the data that we collect from the real cases are being used in the demonstrator. We can scale up, we can combine different things, and then we produce new data, and we can also calculate those, the effect of this. Hopefully, we have this simulation, this hybrid approach, and this simulation support, because you can guess we had a very hard time in the pandemic situation to get users to produce data. So we are able to scale up what we have collected. One thing we learned here also is it was not so easy to put in place because we have data models that are quite complex, and the data provider provide data with different we had to correct formats and so on. So it's quite complex things, a lot of data. And if we want to compare different solutions in the future that are implemented in the next, in different cities, we have to make standards for those data, for collecting them, and for actually calculating impact. But Green Chart is not only about technology. Hopefully, we also have a lot of cooperation with different cities. We have cooperation with what we call uptake city, a group of cities that explain their needs, and we also present our results. It was a very fruitful way of working. Then we learned that at the moment, the city we work with, smart energy management is not seen as main topic within e-mobility. The city are very concerned by we have to charge, we have to install charging point, but it's not only about that. Where does the energy come from? This is an essential question. So also some work we did, and with Michael that is here, my colleague Michael from Bremen, we developed guidelines for e-mobility for sustained urban mobility plans, SUMPs. Yeah, and we have here, we have here a brochure, and if you are interested, we can give you this brochure. Mm-hmm. So what we learned also here is that when urban planning is concerned, e-mobility is not the #1 priority because, well, we have other concerns. We have to reduce the usage of car. We don't have space for all this charging point that everybody is going to have his own electric car. So this is a very important issue. So we have an impact evaluation. I'm not sure I have time to go through all the points. 2 minutes? Okay. First, related to, so we have group our result according to different evaluation topics: society, people, transport, energy, environment, and economy. I can tell that regarding to the acceptance in Oslo of the solution was very high, and people are very interested because the electric price are just jumping up, and so they want to reduce the cost. So this also is a motivation. On the other side, in Germany, we see that people are maybe not so motivated to share car. Not yet, but the people who did it, they were very happy. I go quickly through that because you can read our report. I can tell you also that in Bremen we got a reduction of CO2 of 75% in our demonstrator. So it's very, very high. Oops. Related to what needs to be done in the future. So about research, we need research related to advanced booking and decision support for advanced booking. This is something that we could have come longer, but have not. So this is something that we see is very important. We see also that we need to scale up our experiment about smart energy management. We have focused on residents, but we would like to have large places. Yeah, I see that I have short time, but I can say that you will be able to learn more about Green Charge because we are going to have a collaboration. We are starting that now with Civitas, and we are going to contribute to a course relating to the charging infrastructure for e-mobility. Then, maybe the final conclusion is that we have to have a holistic planning for e-mobility. It's not only about electric vehicles, but it's also, for example, about active modes. We have also to support local authorities. It's not about installing charging points, but and then come to something more elaborate. But we should make the big step now and avoid to implement something that is ineffective. And then we also have to engage the industry, and we see that it's very segregated. We have people producing car, people producing battery, people doing with planning transport, and we have to find out how we can work together better. And I think it's my last slide. Thank you.
Thank you again. Thank you again, Jacqueline, also for staying time. Thanks a lot for skipping. But I know you can find all the information additional in the website or via the publication. It's here if you want to grab a copy. The second project presented today will be Macer, just finished as well. As finished 1 month ago, and we will hear of the result of business cases that were demonstrated in 3 urban areas, in particular Malaga, Berlin, and Stockholm. Again, Berlin. This presentation will be a unique venue while showcasing the final results achieved, as well as the products, the apps, and the lessons learned during the project. I give the words now to Angel Moya, an industrial engineer from the Polytechnic University of Valencia, UPV. Floor is yours, please. Thank you.
Okay, good afternoon, everyone. And I'm very happy to be here and share this session with our sister project Green Charge and also with Untitled EV. As Ido said, Master project ended last month on February. We tested our business cases in 3 cities, Malaga, Berlin, and Stockholm. We had 6 million of budget, and the main aim of the project was to test innovative business models in order to reduce the cost for charging infrastructure deployment and facilitate the large-scale deployment of the electric vehicles around Europe. In order to achieve this, we established at the beginning these 4 objectives, to establish an innovative and sustainable business model for smart mobility, deployment of interoperability platform, the integration of the e-mobility in the urban plans, and also the integration with the smart grid services. So in this presentation, I will present you 5 of the 10 business cases that we tested during these 42 months. The first 2 business cases that I will like to show you are related with the e-car sharing services. We did 2 different approaches, one in Berlin and another one in Malaga. The first one in Berlin was in 2 new neighborhoods in Berlin that the company Gebobag has. Gebobag is a German property company, and for them was important to reduce the amount of the car ownership in order to reduce also the building cost for parking garages, having in that way more space to construct apartments. So for that, they did an agreement with a fleet operator, and they put 4 electric vehicles for the tenants of these 2 neighborhoods. In the case of Malaga, they had 4 vehicles in the city council for the council purposes, and they put these 4 vehicles at disposal of the employees, So they could use these electric vehicles after working hours for their personal purposes. With that, of course, we reduce the CO2 emissions, and we help to raise awareness on electromobility, because the employees know the technology, and maybe in the future, if they have to buy a new car, they will choose an electric one instead of a combustion car. Also, one of the objectives was to encourage to reduce the use of the private cars and to optimize the use of the municipal fleet. So to achieve that, we developed within the project these 4 products, 2 apps to book the vehicles, and then we had also a mobility display where the citizens of one of the neighborhoods can consult in the map the footpath to the bus and train station, also real-time information regarding the e-car sharing system and charging points. And the objective was to give this information to the citizens in order they can choose the best economic and environmental option to move. And also for Malaga, we had a dashboard for the managers of the city council in order they know the numbers and make improvements in the system. Here you can see some of the results that we had. Take into account that all these business cases were tested just after the lockdown, so with still some mobility restrictions and people working from home and so on. But at the end, we had in Berlin more than 200 registered users. That it means more or less 20% of the housing units. That it is a good number. So they are thinking to extend the demonstration by another year, and including this service, this e-car sharing service, in the Kilowatt portfolio. And in Malaga, we had 76 employees using these 4 electric vehicles cars. We save CO2 emissions, and we had a high potential to increase because the municipal fleet has more than 500 vehicles. So if they extend this model to do the rest of the areas, we had an important potential rate. And the feedback of the users was very good. As you can see here, 90% of the people believe that the service can be extrapolated to all the citizens, and includes even they thought that they could replace the second familiar vehicle if the service is maintained in the future. Of course, we had some things to improve, that, for example, the autonomy of the vehicles, because they thought that it was a little bit short for some purposes. And here we had another business model that it was called Smart Park and Charge, because, as you know, one of the problems of the EV users and the city planners is find in semi-public space, and another problem is that the parking places for electric vehicles sometimes is wrong use by combustion vehicles, or also by electric vehicles that stay in the place more time that they need to charge. In order to solve this, we had two different approaches. In Berlin, we installed 4 digitally controllable parking barriers, and in Malaga, we installed 2 intelligent camera systems. Okay, and here, okay, and here you can see also the products that we needed in this part. In Berlin, they used this app in order to book the parking place and to select the barrier in order the barrier goes down and they can park and charge. And for Malaga, we deploy a Meister e-parking solution that takes the pictures from the camera, and thanks to a trained a neural network, the system can know if the place is free or not, and this information goes to the app, and the EV users can see in the app if not only if the charging point is free or not, but also if the parking place is free or not. And the last business case I wanted to show you is the business case that we tested in Stockholm. It was about smart charging. Stockholm sometimes can find problems in power demand in some particular nodes of the distribution grid, especially in winter, and even more with the expected increase of the number of the electric vehicles in the city. So in order to address this problem, we did this business case that with the aim to stabilize the low voltage electrical grid by controlling the electric vehicle chargers. For this, we developed the product Meister Smart Charging and Storage Platform that takes the request from the DSO and gives the information to the CPO thanks to an optimization algorithm in order to reduce the power in some charging points. Here you can see some of the numbers of this business case. We tested this for 2 months and we had almost 3,000 sessions. The maximum power steered was 10 kilowatts, and the maximum number of charging points reducing the power together at the same time was 3. And with this we can do also the charging points infrastructure most cost efficient and avoid problems in the grid. And also for the DSO is really interesting because they can offer flexibility services. So here I pointed 11 points divided in 4 categories: technology, environmental, economic, and regulation, with the expected impacts of the project. I won't read each by one, but you can see there some of the things that I commented before, like for example, to reduce the number of combustion vehicles, reducing the number of private cars thanks to these mobility services, also to reduce the CO2 emissions, a significant potential to increase the usage efficiency of parking spaces, the potential to provide a significant amount of flexibility services to the DSO, etc. Okay, so what are the future research needs identified thanks to this project? For example, vehicle to grid, because at the beginning of this project we tried to test this vehicle to grid, but we couldn't because also 1 or 2 car manufacturers permit the use of this technology. We had also some problem with the regulation, and it's still an open field to research, we think. Also payment transactions using, for example, blockchain, and also the integration in the apps with the low emission zones, for example. The contribution to the climate objectives I told before: CO2 savings and raw material save by reducing the use of private vehicles. And of course, some of the partners of the project, we are continue working on this field. For that, we create a association within the project that it is called EMEC, that you can search in the web, and also we are working in other projects like Userchi. So that's all. Thank you very much.
Thanks again, Angel, and thanks also for staying in time, so we have the time for discussion. An interesting presentation, both. I think we'll have many questions after, but it's now time for the third project presented in CTV, large demonstration of Ucentric's urban and long-range charging solution. So it's a project that demonstrates an innovative set of charging infrastructure with 7 demonstrators with e-roads, bidirectional charging, and grid integration for charging infrastructure. Miguel Zarzuela, project manager at Circe Technology Center. He's an engineer from University of Zaragoza with a specialization in the energy field, and will present this project, which is a larger one with more than 18 million projects starting in 2020 and ending in 2023. The floor is yours. Thanks again.
Thank you very much, Guido, for this kind introduction. Thank you very much also for AirTrack and the European Commission for facilitating this physical meeting. I will go straight to the point, as well would like to share with you a lot of insights of this project. I will start with a short question. Have you used today a vehicle to arrive to this meeting or to arrive to Brussels? Probably the answer will be no. And so we are trying to solve the circumstances of why you have not used an EV vehicle for that. Inside EV is a project which is focused on the development of new charging technologies to improve the user perception of electric mobility. We have 7 use cases across all Europe. I will go in detail of at least 6 of them. This is a big project, as Guido have said. We have about 90 million budget, from 15 million comes from the European Commission, very large consortium, 33 project partners from all kind of expertise, including automotive manufacturers. 4 years project that will end in the end of 2023. So, what we aim? We are going to develop new charging solutions to solve the issues that the users may have. So, how to start? We are searching, we are investigating with the users their preferences and expectations concerning vehicle recharging. The solutions that we are providing are wireless charging and conductive charging. This project is very focused on interoperability. So concerning wireless charging, we are developing 3 use cases that will be interoperable between the 3. We are considering static charging, also dynamic charging, up to 130 kilometers per hour. We are developing 30 kilowatt coils modules that we can add to reach higher power for charging bigger vehicles. And also we are developing low-cost scalable V2G chargers from 3 kilowatts up to 200 kilowatts for any kind of circumstances that will need to provide ancillary services or even load balancing, or to use the energy from the vehicles to power any household or any industry at peak times. We are also developing a decision support system for mobility planners, just them to find the best spots and power required by the penetration curves of the EVs. And we are going to develop a business model for all of the use cases that we are going to develop in the project. Right now, we are about half of the project. We have ended the technology development. And in this moment, we are finalizing the engineering process of all the use cases in order to deploy them between this summer and this winter. The next year ahead will be the demonstration phase and also the evaluation of the user perception in these new charging technologies. Let's start with the beginning. We are evaluating the concerns and the perception of the users concerning electric vehicle charging. So we are making a combination of surveys, face-to-face interviews, discrete choice experiments, just to say what you prefer, A or B, just to find what are the major importance of all the possible variables that we can interact with the charging infrastructure and the electric vehicles. So this is a process that is now taking place, so I don't have the full outputs of this task. But what we know now, well, if we ask anyone about EVs, is that they want cheaper vehicles that charge faster and drives longer. But this is not exactly what we need to to cover. They need, we have extracted that they need seamless and reliable charging, fast and interoperable charging for travels, and also they are starting to want to integrate the electric vehicles into smart grids. Therefore, some households start to have self-consumption through photovoltaics, and they want to store their energy and use their electric vehicle as battery just to power the house when there is no sun. Grid operators also has a big role on this. They are interested also in use the EVs as storage for renewable energy sources to afford more renewable energy in the grid, and also to be able to manage this charge and discharge to provide ancillary services as frequency, voltage, and reactive regulation directly from DSO and TSO. What's very good in this project is that we have 3 OEMs, 3 automotive manufacturers that are providing vehicles and modify them in order to use all the use cases with commercial vehicles. We have Group Renault that is providing 2 Renault Zoes and 1 Master, Stellantis that is providing 1 DS, and Iveco that is providing 1 vehicle for CCS bidirectional charging. I will start with wireless charging. As I have introduced, we have designed a common coil for all vehicles. It's based on a 30 kilowatt coil that will be installed in all of them. It's very complex to find interoperability between all the use cases because we have static charging and also charging up to 130 kilometers per hour with some misalignment, changes in the height of the separation between the coils. But we have found a good point of operation for all of them. So we are really happy to use, we are able to use the same vehicle in all of the demonstration sites. We have designed not only the coil, but also the shielding of the vehicles because it is affecting also the electromagnetic fields that are interacting with the control of the systems. So this is a complex situation, but that we have solved within these 2 years of the project. First one, more simple, but it's not simple at all. 50 kilowatt charging, wireless that will be tested in Zaragoza. This charger will reach between 95 and 97% of efficiency in concerns with if we compare it with a conductive system. So we have achieved a really good operation point. We can accept up to 25% of misalignment. And we are right now developing the vehicle detection and communication to start the charging just when the vehicle is parked over the charging spot. This use case is designed for a taxi queue, so you can imagine a taxi waiting on a stop, charging at 50 kilowatts while he's waiting. The next taxi moves, so he moves to the next stop, also with a wireless charging, and he continues charging. So he uses all the time available for charging, but he's able in 1 second just to move to the next spot or just to move the customer to the destination. Also, this system can be lower in power to find a premium experience at home with low power inductive chargers. Let's move to a more complex situation, charging on the street, 50 kilometers per hour, street with traffic lights. This system is a complex one of the static charging. So we have here a line of coils in the ground that are fitted with each one with an inverter. So the inverter is powered on once the vehicle reaches that zone. So the control system here and the communication system vehicle to infrastructure needs to detect the vehicle, to pre-activate the next coil and to deactivate the previous coil in order to charge the vehicle while it's moving. In the case of the master, we have a 3-coil system, so we activate 3 coils at the same time, and we have developed a system that does not interact between them because there is some mutual inductance between the coils, and we have solved just to separate the magnetic fields between them. Last wireless test track. Why not? 130 kilometers per hour dynamic charging. reaching 90 kilowatts charging in the master and 30 kilowatts in the ZOE. We have developed here longer coils, so because the vehicle will be less than 1 second in each of the coils. This will be a test track in Versailles, outskirts of Paris, and it will be 8 tracks of 10 meters just to develop this business case of how it will work and a full e-road to charge while we are driving. This will be in place by the end of the year, so follow the project for the next updates, as I believe this will be very interesting to see in place. I will move faster. This is one of the ultra-fast charging demonstrators that will take place in Tallinn, in Estonia. This is a 200 kilowatt charger, but here what is very special is that it includes communication, direct communication with the TSO and the DSO, so they can check in real time what is the status of the grid, and to put their commands to control the reactive and the active power for frequency, voltage regulation, even load balancing of the grid. The other use cases are conductive. We have a big charging hub in Torino that has more than 10 low-power CCS bidirectional charging points. It's also connected to the tram line, so we can use the available energy from the recharge of the trains of the city. We have also in Zaragoza another bidirectional charging. This one is 25 kilowatts. It's performing the same ancillary services than the one in Estonia. And we have also first test of bidirectional charging on AC, therefore using the onboard charger of the vehicles. These are Hyundai Ioniq vehicles, and it's tested in Utrecht. So all possibilities of B2G charging and ancillary services provided by the electric vehicles. This is a decision support system that we're providing also in the project. This system is fed by the user behavior and the penetration curves of the vehicles and also of the chargers. We develop cost-benefit analysis, and we provide to the mobility planners and the decision makers the optimal sizing and siting of charging points and its grid impact in order them to be able to plan the mobility plans of their city and also the charging requirements. Just finishing, we are paving the standards of inductive charging. We have detected that we have to work with OEMs to do this, because we have to develop or to build at the same time the coils in the vehicle and the coils in the ground, because they are very interrelated. So we have to find a common ground of operation of all of them, just to anybody that develops this kind of system are interoperable between them. Something that we are developing also here it's very important is the communication between the vehicle and the infrastructure in high-speed environment, but with a very low time of response. And also we are developing a line-keeping assistant in order to reduce the misalignment in these e-tracks. Concerning the conductive chargers, where we are developing B2G test in CHAdeMO and CCS connectors, we believe that this is going to change in the following years, because this will bring the electric vehicle a new position in the grid, and also it will be an added value for the users and for the grid operators. Therefore, it will be a win-win situation that will increase the benefit of having an electric vehicle. Just finishing, we have developed a Synergy Club with the same with the projects that were funded in the same call that in SciTV. These are User Chai, eChare for drivers, and also Smart project was for an Interreg project. And also with this kind of events, we found a lot of information from projects that are doing the same, maybe 2 years before or 2 years ahead. So it's really good to have this kind of synergies to benefit on the work that everybody are doing on this. Just to finish, of course, the goal of the EU and the European Commission is to fulfill the objectives for 2030 that indeed are to get rid of fossil fuels and to put on the street at least 30 million electric vehicles by the end of 2030. With this project, we are developing new business cases, new technologies, new functionalities to electric vehicles to increase their uptake in the market share and to reduce their cost of them. Therefore, I will end almost in time. If you have any question, feel free to contact me or to visit our project on insightdb.eu. And thank you very much.
Thanks again, Michael. Now I will leave it to Ian to do the follow-up with the question.
Okay, thank you very much. Thank you very much for some excellent presentations. Very interesting. We see basically how complex charging can be. It seems like it's simple just to plug in, but in the end, it's actually a very complex process, which we have to be in charge of. I'd like to open the floor to questions, and I would please, we only have 17 minutes left for questions, so please keep your questions focused on the presentations. And the first question is here.
Hello, my name is Marco Tella, Extreme Engineering, a newly founded company to provide consultancy on electromobility. So, my question is very simple to the last project presentation, very interesting. Wireless charging is a reality on mobile phones, is standardized, is efficient, is widespread. It works, definitely, since many years. Wireless charging for cars is still a nightmare. There are a lot of problems still to be solved. There are no standards, nothing at all. My question is, where it could be simple, but still not deployed, is the wireless charging for two-wheelers and the like. So there are a lot of two-wheelers on the roads, even more every day, electric bikes, scooters and the like, and nobody is thinking about deploying or making solution, designing solution for wireless charging of this. Why?
Okay, I'm glad that you put this question on the air, because indeed in Inside TV we are doing this for two-wheelers. I didn't have the time to present, but we are doing this for scooters. It's an inductive charging that you put it on the handlebar, and you have a charging station close to the two-wheeler when you park it, and it's also anti-vandalism scenario. I agree that this can be extrapolated to mopeds or to e-bikes and motorcycles. Here the topic is if you raise the power, you increase the weight of the inductive charging, and sometimes you have the space or not for this. But in the demonstration of Zaragoza, we have at the same place the static charger, the conductive bidirectional charger, and also the two-wheelers charging spot with inductive charging.
Joseph down there.
Thank you, Miguel. Next question?
Thank you, Guido.
Thank you, Guido.
Thank you, Guido first. My name is Joseph Hochzeller. I wanted to ask you about truck charging. You had shown dynamic charging, there's also static charging. What you are thinking about the dynamic charging, there are different approaches today in the various countries. What is based on your experience and your thinking is the best one, or what you would recommend in this direction?
Well, to be fair, this is a topic of cost. Of course, having an infrastructure in the middle of the highway is expensive. Good point of this, I believe that the automotive sector will move first on offering this wireless charging as a premium functionality for charging at home. Therefore, you just park and charge. And you avoid all the wires, but this just will be a premium functionality, will not be added value rather than eliminating the wire. So if you want to pay for this, no problem, you can achieve it. Dynamic charging is more complex, as you have seen. What I believe that will work in the future, we are developing, and this was a really brand new development, very simple coils with only one turn. Therefore, we just put one cable in the asphalt, and the civil engineering is quite cheap, let's say. You just have to pay the cost of the cable, and the control system will control when to power on the coil. But they are, I have to say, that very simple, and the business model of this is quite good in relation with the things that we have seen in other charging infrastructure concerning wireless, because they are embedded on some regimes to dissipate the heat, so a very complex installation and manufacturing of the coils. And let's see at the end of this project, because we still have to test this new infrastructure that will be in Versailles. But I believe that the potential of reducing cost is very promising, and if this works and is fully implemented, we can see maybe on outskirts of the cities ring roads in which you can recharge up to 100 kilowatts and charge while you are driving. We'll see, but in the end, it's a matter of cost.
Thank you. More questions?
Yes, my name is Pascal Loas from the Luxembourg Institute of Science and Technology. I have a question for the first presentation, Jacqueline, I believe, which is in your simulation platform architecture and models. Why didn't you include the vehicle-to-grid scenarios? That looks quite interesting.
Yes, indeed, we have this V2G. I did not name it in my presentation. But we also have another project that show actually that there is a lot of loss, 18% loss. So at the moment, we think that this is not something to go for. Yeah. So yeah. Mm-hmm.
Thank you. Next question. I think it's Franz.
We are talking about charging solution, Franz Geier, my name, and I would like to propose a solution. One solution is, why not having a strategic that's a question, why not having a strategic objective of having 25% of the parking slots within cities electrified as a strategic goal for cities? That's one of the questions. And another question is, from a user perspective to all of you, what would be the three must-haves for charging solutions? A question to all of you, maybe.
Franz, can you repeat the question? It was difficult for you.
Can you remove your mask?
Yeah, so what the first question was, what do you think about a strategic goal for cities to have every fourth parking slot electrified by 2030, for example? And the second question is, what are the top three must-haves from your side for the customer perspective regarding charging?
So, Jacqueline, this is a question for you. Maybe also for Miguel to follow up on Jacqueline. Okay, thank you.
Okay, the first one was, I remember the second one.
Mandatory parking spots.
Oh yeah, okay. First I think that we have to change behavior. We cannot say that every car, we are going to have a transition to electric mobility, and this doesn't mean that everybody will own a car in the future. I think we should put that on our heads. We have to share more. So actually, it's not about making all parking space with a charging point. It's about reducing parking space, going for other modes of mobility, like active mobility. I bike this morning when I came here. It was very fine. Okay, so this is one thing. And the second question is about from the user's perspective. I think something maybe I did not talk much about in my talk. It's about local energy production. I think all the energy we need for charging, it has to come from some place. And I think that it's very important to have this in mind. For example, like in large residence building blocks, we can put PV panels on the roof, and we have to make the best use of this energy. So this should be a very important concern for users. How can I produce some of the energy myself, and how can I make best use of it? Mm-hmm.
Thank you. Miguel?
Sorry. If I may add for the first one, I will refer to a newly recent law in Spain that is related with the climate law. From the 1st of January of next year, all parkings that are available in any building or in any parking slot will have to provide at least one charging point per 40 charging slots. So with this measure that will be available, will be applied not only to new infrastructures but also to the existing ones. I believe that even if you don't have a charging spot at home, you will be able to charge your vehicle. I will just showcase my own case. I live between two cities. In one of them, I have a charging spot. In the other one, I don't have. But only if I go to the supermarket whilst I'm buying, I can charge the vehicle. Or if I go to the cinema and the 2 hours I'm charging, I'm able to use the vehicle within the city for 1 week. So if everybody within their daily life is able to charge at work or even doing some social activities, not everybody has to charge the vehicle at the same time, and not everybody has to charge the vehicle at home. So I believe that we can solve this with this kind of solutions that should have an umbrella of common development.
I would also like to pass the question to Angel about the business case perspective. Would you like to comment on that also? About the parking spaces and the priorities from users in terms of charging. Okay.
For example, in our project, we tested the two business cases, Smart Park and Charge, only in semi-public spaces. And one of the reasons was that, because in public spaces, we didn't still have any, for example, regulations to put this kind of barriers that we tested, or to put the cameras, and also, for example, to give signals to electric vehicle users to remove the car if they have finished the charge, for example. So these kind of things are still open for city councils, and that was the reason why in our project we only tested this in semi-public spaces. But I think it's an open question to go indeed.
Okay, thank you. Next question. There's somebody back here. Joseph.
A second time, if you allow.
Yes, of course.
Jacqueline, for your question, your perspectives with more, your investigation, great ideas and everything is fine from the grid side, but not so much from the user side. And based on this one, what do you recommend to China now? In China is the situation that they are queuing 4 hours, 6 hours for the charging station in the big cities. The use of electric vehicle. And therefore, a lot of booming in internal combustion engine starts there. What we can do here in Europe to avoid this? That would be my question. So there are too many vehicles in Shanghai, Beijing, and they have less charging stations, or they need to queue in the front of the charging station to get access to the charging station, and then they have, based on the smart charging, to stay half an hour to 40 minutes longer there to get the energy. This you have to avoid.
I think we have to have a more holistic approach to mobility. It's not only about everybody owning a car and it's also, we have active modes of mobility. We can go, we can bike, and we see that actually in the pilot city that we had in Green Charge, Oslo, Bremen, and Barcelona, a lot of people are actually, half part of the people are active, they bike, they go. So I don't know what people are thinking. How can we achieve the goals of the Green Deals? How can we be environmental friendly without changing our way of behaving? We have to do something. This is very important. And maybe it's more important than all technology we are developing. Actually, what we are doing is that we are developing technology for problems we are creating. We build big cities. The city is growing and growing and growing. This is a problem. Let's go back to middle-sized city. We have to change. I don't know.
Yeah, but Shanghai is like that. So you have to solve the problem in Shanghai.
Huh?
Jacqueline, I think it's a combination of both, and I think some of the answers to the question are in the presentations. For example, the predictive control was an aspect from Green Charge, as well as the reservation systems and the blocking of the spots. So you answered some of my questions in your presentation. Thank you very much. Regarding how do you keep a spot free if you've reserved it? And some of the solutions are already out there, but it's not just a question of the technical aspects, it's also the user-centric points. So I'm looking for more questions. We want to get some more dialogue here. Here's a question.
Thank you very much, and thank you for the great presentations to all. I'm Chala from Syrio Clean Road Energy Storage Technologies. So my question, I think, more for the Miguel and also Jacqueline, I think. You mentioned about the smart charging algorithms using AI. So also this is a very hot topic for charging optimization. Like, which kind of algorithms did you use in the project? Did you develop it during the project? So I'd like to take a bit more information about that. Thank you.
I don't think I mentioned AI, but I'm not sure I mentioned AI, but indeed, in the solution, in one of the solution we have, we are using AI, but we did not develop that in the project because we are an integration action project where we have integrated technology from different technology providers. And of course, we have to further develop to integrate. But so I can recommend you to look at what eSmart system is doing on that field because we use their technology. Mm-hmm.
In Initiative project, we have two pilots concerning smart charging algorithms. Some of them are developed by Green Flags, some of them are developed by WeDrive Solar, some of them are developed by Total Energies. We have a lot of partners involved on this topic. Not very sure if they use AI. I know that we have 40 charging points in the Amsterdam region testing these smart charging algorithms. So with this information, we may have the data to improve the algorithm, but at this point, I cannot provide further information about this.
So thank you, Miguel. Do you have any comments as well? Angel? Yeah.
In our case, our optimization algorithm in our smart charging and storage platform was developed by Certh from Greece, but that's all the information I can provide you.
Okay, unfortunately, my phone just reminded me that we're out of time for today. Thank you for the audience for good questions, good dialogue with us. Thank you especially to the presenters for very good, excellent presentations. And the next session will be starting right now, and it's the green vehicle new vehicle design for usage models in room Newton upstairs. So thank you, and we'll see you at the next presentation. Thank you.
Just one reminder, there is also an exhibition outside a couple of booths, so AirTrack, CCAM 2.0, and also a booth of the Commission. If you have any questions, something, please feel free to come and ask us. Thanks.